We're moving on to Unit 2. In Unit 2, we actually just have one topic to learn. That topic's called mean absolute deviation. So first, let's talk about what the name of this topic means. So we have mean absolute deviation. Who remembers what the word mean means in math? Yes. Mean is the average of a set of numbers. Let me write that a little darker for you. So mean is the average of a set of numbers. And absolute is referring to the absolute value of a number. And the absolute value of a number is the distance value as in the distance from 0. Are you capable of traveling a negative distance? Can you go negative 3 feet? No. So when you're talking about the absolute value, you're talking about the distance that a number is from 0. And because you can't have a negative distance, your absolute value is always positive. And then deviation is just talking about the variation of the information. A deviation is just the difference, how a set of data differs from the rest of the information within that data. So this is just the variation. So now let's look over here. If mean absolute deviation broken down means that mean is the average of a set of data, absolute is the distance a number is from 0, and deviation is the variation of that information. That means the mean absolute deviation is the average of the distance of each value in a data set from their mean. So mean absolute deviation is the average of the distance of each value in a set of data from their mean or their average. So we're finding the average distance from the average of a set of numbers. Now to do this, we're going to create a chart that's going to help us keep track of our information. So on your paper, I'd like you to draw 3 columns. Okay, at the top of this first column, I want you to write the word data. The top of the second column, I want you to write the word mean. And at the top of the third column, I want you to write difference. and then put a plus sign in there, a positive sign. And I'll explain why we put a positive symbol here in a second. So this question here says, a list of numbers is shown below. Find the mean absolute deviation of the given numbers. So we're going to start by putting the numbers that they give us here in the data column. We're just going to list what the numbers are. So we have negative 0.3, 1.3, 1.7, negative 1.3, and negative 0.9. So now that we've listed our data, we need to find the mean or the average of this data. Does anybody remember how to find the average of a set of numbers? We're going to add up all the values and then divide by how many values there are. So when you're finding the average, you need to include your negative symbols. So I have negative 0.3 plus 1.3 plus 1.7 plus negative 1.3 plus negative 0.9. I'm going to hit enter. And we have 1, 2, 3, 4, 5 values. So I'm going to divide by 5. And I find that my average of this data is 0.1. So in this mean column, across from each value, I'm going to write 0.1. Now, between the data and the mean column, I'm going to put a minus sign. And between the mean and the difference column, I'm going to put an equal sign. And down between these sets of numbers, I'm going to do the same. Because to find my difference, I'm going to subtract my data minus my mean to get the difference. The reason I have you do this is so that in your mind, you remember to go from left to right and don't accidentally subtract the mean minus the data, which would give you a different answer in some cases, which would affect your end result. So now we're just going to subtract straight across. So I have negative 0.3 minus 0.1. And I get negative 0.4. Now we're talking about the distance this data point is from the average. So that means that we can't have a negative distance. So we're going to ignore the negative sign and just write the 0.4. We'll do the same thing here. 1.3 minus 0.1, and we get 1.2, so we'll record that. 1.7 minus 0.1 gives us 1.6. Negative 1.3 minus 0.1, we get negative 1.4, but again, we're going to ignore the negative sign. That's what this positive here in parentheses means. So we'll just record the 1.4. And then lastly, negative 0.9 minus 0.1 gives us a negative 1, but we're going to ignore the negative sign and just write 1. Now you have this last part outside of your column. In this space, you're going to write the word sum, count, and mad. We are now going to add up these values, and they're going to go next to our sum amount. So we have 0.4 plus 1.2 plus 1.6 plus 1.4 plus 1. Our sum is 5.6. We're going to count up our data points again just to make sure we have all the data points. If we started with 5 over here, we need to make sure we still have 5. Otherwise, we missed a step and we're going to get an incorrect answer. So we have 1, 2, 3, 4, 5. And I like to throw a little division symbol in here because you're going to take your sum, divide it by the amount you have, which will give you your second average, or the average distance that your numbers are from the average of that data point. So we're going to take this 5.6. We're going to divide by 5. And our mean absolute deviation in this case is 1.12. This is your answer. There are a lot of steps to get to your answer. Unfortunately, there is not a faster way to do this. So what does this number mean? This means, on average, each of the numbers from this list is about 1.12 steps away from the average of the number, of the sets of numbers themselves. What that means is you can count on the average being relatively accurate. The larger your mean absolute deviation, the less accurate your average is. So that's to say, if we took a test in this class and I told you that the average score was an 85, one might assume that most people got around an 85. However, you could also get the average of 85 if most of the students made 100 and a handful of students made a 0 and there was nothing in between. You could still get a class average of 85, but that average of 85 wouldn't actually provide you any meaningful information about the test grades because 100 and 0 are both really far from that average. And so saying the class had an average test grade of 85, in that case, wouldn't really represent how well the class did as a whole. So again, the important thing to remember is that the larger your mean absolute deviation, the less reliable your average is. So when we're looking at mean absolute deviation, we want to have relatively low mean absolute deviations. And that's how we'll know that our information is accurate. So another thing that I provide for you is this template that you can use to record all of your data and run your problems. Some students in the past have found it helpful to change the word here. Instead of difference, they like to call it the distance, because it reminds them that the number needs to be positive. Because we're just talking about how far your data point is from your mean. And remember, we need to subtract data minus mean, and that will equal your distance. So here on the bottom, you have a problem. It says, a list of numbers is shown below. Find the mean absolute deviation of the given numbers. You can create your table over here on the side, or you can pull up this document in your notebook and collect your data points here. Go ahead and work on this problem and find the mean absolute deviation, remembering to keep your third column positive.